Hi class, today we're learning about solving linear trigonometric equations. So really we're just taking a trigonometric equation and solving for y. So we actually already did this in chapter 6, but it's just prepping us for what we're doing next class, which is solving quadratic trig equations. So most of this today is actually a review, but it kind of just sets it up comparing identities versus equations. So we're going to use our graphical knowledge and our algebraic knowledge together to solve this. So what we've been doing the last few days is identities, and an identity is true for all values in the domain. So for example, if we have sine squared x plus cos squared x equals 1, that's an identity because no matter what x value we put in, this will be true. So that is an identity, okay? But something like this, 2 sine x minus 1 equals 0, that's only true for certain values of x. It's not true for every value of x. So these we can solve and actually find what values of x make this true. And since trig equations are periodic, okay, these solutions keep coming up over and over again, so we're always going to be given a specified interval. So you're going to say, I've seen this before. So this example 1 should be a review. So solve 2 sine x plus 1 equals 0, where x is between 0 and 2 pi. So we can see that this sine curve has a period of 2 pi. The period hasn't been altered at all. So when it says between 0 and 2 pi, that's only going to be in one complete cycle. So the first thing we want to do is rearrange so that you have something in the form sine of theta equals a number. Okay, so we're going to move the 2 and the 1 over. So you get sine x is equal to negative a half. Okay, so determine how many solutions are possible using a sketch. So you have two options here. Either you can sketch this original guy. So 2 sine x plus 1. So it has an axis here at 1. Okay, and so it would be starting on the axis and then going up 2 above and down 2 below, and then back up to here. So solving with this equals 0 is equivalent to these two numbers here. Okay, or you can graph sine x, okay? So you can graph just your normal old sine x. Okay, and then look to where it would be equal to minus a half. So that would be roughly here and here. Okay, either graph is valid. It just kind of depends which one you want to go off of. So now you want to draw two terminal arms in the proper quadrants of the Cartesian plane. So sine is negative in 2 quadrants. So you would have one terminal arm here. So then that's x1. Okay, and sine is also negative in this quadrant 4. So that would be x2. Okay, and you have to think, what do x1 and x2 have in common? They have the related acute angle in common. So you might notice that 1/2 is a ratio from one of our special triangles. So remember, always use special triangles where you can. So we have here 2, 1, and root 3. So which has a sine of 1/2? It's pi over 6. Okay, so beta, remember, is the inverse sine of 1/2. We always use a positive number here. Okay, you need to remind yourself of that. When you're finding beta, this should always be positive. Only for beta, because beta is always acute. So using our special triangle, we can determine that beta is pi over 6. If you had used your calculator, you would have gotten some crazy long fraction or decimal, whereas pi over 6 is an exact radian value. So now we use our work from step 2 and 3 to determine the answers. So here we can see x1 is just pi plus beta, so pi plus pi over 6. So you get 7 pi over 6. And x2 is equal to 2 pi minus pi over 6. So 11 pi over 6. And those are your two answers. Okay, life is good. All right, so we're going to go through these 3 steps for the next 2 questions. And then example 4, we get into a real life context. So you'll notice here we get back into degrees, okay? So that means that you got to switch your calculator to degrees, and we're going to actually answer this question in degrees, okay? It's important that you're able to do both. So we rearrange this to be tan x equals 2 minus 1 is 1 divided by 3. So tan x equals a third. Sorry, I lied. I was just checking that for a second. You're like, what's Mrs. Weens doing? This bracket means that this 3 was distributed. So we actually have to, let me do this in more steps first, just so you don't make a mistake. There we go. Okay, so you can distribute the 3 first. So you get 3 tan x plus 3 equals 2. So now I got to subtract a 3, which gives me a -1, and then divide by 3. So you get tan x equals -1/3. So again, notice the period hasn't changed at all. So we can graph quickly what this would look like. So we're looking between 0 and 360 degrees. So remember that tan has a vertical asymptote at 90 degrees. And then again at 270 degrees, right? Because it's both of those places, it would be vertical as you go around the Cartesian plane. So then it looks like this. And then that's where 360 is. So where is it equal to -1/3? Well, there's going to be one answer here and one answer here. So now we got to find those 2 answers. So we set up their Cartesian plane. There are 2 quadrants in which tan is negative. It's negative in the 2nd quadrant, so that's x1. And it's negative in the 4th quadrant, so that is x2. So now we have to find a related acute angle. So the inverse of tan of +1/3. Now we use your calculator in degrees, okay, because the question is in degrees. So 1/3 is not from a special triangle, so we just use our calculator, and that spits out 18.4 degrees. So x1 is just 180 degrees minus 18.4 degrees, so that gives us 161.6 degrees, and x2 is 360 degrees minus 18.4 degrees, so that gives us 341.6 degrees, okay? And those are our 2 answers within the given interval. All right. So here's when you have an argument. So this is where we have to bring our best friend u back to play. So let's rearrange this, okay? So we have to distribute this -2 first. Okay, so we get -2 sine 3x minus 8 equals -7. So then we get sine of 3x equals, so 1 minus 1/2. Okay, so notice that sine 3x means that the period is now only 120 degrees, okay? Notice again, this is in degrees. So to get to 360, it's going to have 3 periods. 1, 2, so good, right? 3. All right, it doesn't have to be perfect because you're just looking at how many answers you need. So -1/2 is going to happen 1, 2, 3, 4, 5, 6 times. There's going to be 6 answers to this, okay? Again, because we have a 3 here, the period has been compressed, okay? It's been divided by 3. So we have 3 cycles within 360 degrees, 2 answers a cycle, 6 answers, okay? So now we do this thing where we let u be equal to 3x. Okay, so now we're just solving for sine u equals minus a half. Okay, so on the Cartesian plane, there are 2 quadrants in which sine is negative. Quadrant 3, so there's u1, and quadrant 4, that's u2. Okay, so now beta, which is what they share in common, is the inverse sine of positive a half. Okay, again, from our special triangle, that's 30 degrees. All right, so u1 then is 180 degrees plus 30, so 210 degrees. And u2 is 360 degrees minus 30 degrees, so 330 degrees. Okay, so now we got to convert these back to u, or back to x, I mean. So we have 3x, and I'll say that's x1 equals 210. So therefore x1 is equal to 70 degrees. And then 3x2 is equal to 330 degrees. So x2 is equal to 110 degrees. Okay, so now we just need to add periods. So one period so this here is the 70 degrees. One period will get us over to this guy, right? The next one on the way down. And then adding a period to this one will get us to this guy. Okay, and then we add another period to the red to get to this guy, and another period to the green to get to this guy. So a period in this case is 360 divided by k, so divided by 3, which is 120. So we just add those periods. So x2 then, or sorry, this is x3. 120 plus 170 is 190. And then we can have x4, so we add 120 again. So that is 310 degrees. Okay, then x5, 120 onto this is 230 degrees. And x6, we add another 120, it's 350 degrees. Okay, and notice that all 6 answers are between 0 and 360 degrees. And if you put them back into this formula, you would get out exactly -7. So there you go. Okay, so now we have a real-life context, and in this case, we actually have an inequality instead of an equality. So we're going to need to have a pretty decent labeled sketch to be able to solve this. So the depth of the water is modeled by this cosine curve. Notice that we're back in radians here because pi over 6. So we're back in radians. So you put your calculator back in radians, okay? And we want to know when the depth is greater than or equal to 2. So notice that this is an inequality. So if we find out where d at t is equal to 2 using algebra, then an accurate sketch will help us determine when the depth is above 2. So we actually have to have a pretty decent sketch here. So I'm just going to rewrite the function d at t in a different order. So 3.5 cos pi over 6t plus 4. So let's just notice a few things. So that means our maximum is going to be 7.5, right? 4 plus 3.5. Our minimum is going to be 4 minus 3.5, so 0.5. Our axis is at d equals 4. Okay, and our period is 2 pi divided by pi over 6. So that's 2 pi times 6 over pi. So that's 12. Okay, the pi's cross off. 2 times 6 is 12. So notice they say in 1 day. So therefore, we're going to have 2 periods to show because 12 hours is 1 period. So 2 periods in a day. Okay, so we want to just draw a relatively good graph. Okay, Doesn't have to be super accurate, but enough to know where it's going up and where it's going down. So we need to have up to 24 hours. So, and we need to separate into 12. So here's 12, here's 24. So then 18, 6, so 3, 9, 15, 21. Okay, and then we'll say that we're going up by, here's our 4, here's 7.5, here's 0.5, right? It doesn't have to be super accurate. So it's a cosine curve that has not been reflected, so that means it starts at its maximum. And after one period, will repeat and end on its maximum again, and halfway through the day, then we'll be at its minimum. Okay, and then that pattern will repeat over here. Okay, and then halfway in between those, it will be on its axis. So this is the general curve we have. And we want to know when d at t is greater than 2. So 2 is about here. Okay. So we'll say that that's d equals 2. So look, we're going to have an answer here, an answer here, an answer here, and an answer here. So it looks like we're going to have something between 3 and 6 seconds, something between 6 and 9 seconds, something between 15 and 18 seconds, and something between 18 and 21 seconds. So then when it's above 2, will be before this one, between these two, and then after this one up until 24 hours. All right, so now we have to actually solve this and then use our graph to interpret the inequality. Okay, so I would encourage you at this point, guys, to pause the video and try to solve this on your own. We've done lots of these. It's a skill that I'm hoping you have at this point. You set it equal to 2 and solve. Okay, so I'm going to go through this rather quickly. Since this part should be straightforward at this point. So you get cos pi over 6t equals minus 4 over 7 when you rearrange. So u will be pi over 6. Cos of u is minus 4 over 7. Okay, 2 quadrants, this one and this one. So u1, u2. So we find beta, which is the inverse cos of positive 4 over 7. That is not from a special triangle. So we just use our calculator and get 0.96. So based on that, u1 is equal to 2.18. Okay, pi minus 0.96. And u2 pi plus beta is 4.1. Okay, so those are our two u values that we need to convert back to t's. So I'm just going to use like a different color just to separate the concepts. So therefore we have 2.18 will be equal to t1. Sorry, pi over 6 t1. So then that gives us that t1 is equal to 4.16 seconds. Okay, and that, if we look up here, matches where it should be, right? This 4.16, that looks right. Okay, so then we can add a period to that to get this other answer. So plus 12 gives us our T2 of 16.16. So that's this one. Okay, so this is just a period. Okay, 12 hours. Okay, and then we can use this one to get the next one. So 4.1 equals pi over 6 T3. So T3 equals 7.83, which matches our graph. Okay, and we add 12 to that to get the next one. So T4 is equal to 19.83 seconds. Sorry, not seconds. What is this? T is in hours. Okay, so like this is the time. So I'll take out the units. Take out the units there. Okay, so So those are our 4 solutions, but now we have to come back and look at the inequality. Okay, so the inequality says when is it above greater than or equal to d to 2. So we have to turn this into time. So 4.16, well, 0.16 of an hour, 0.16 times 60 is 9.6. So we can say that this is approximately 4:10. And then this is approximately, 4:10 a.m. And this is approximately 4:10 p.m. And 0.83 times 60 is 49.8. So we'll say this is approximately 7:50 a.m. and this is approximately 7:50 p.m. So if we go back to our graph, it's above D from midnight, okay, we'll say, to 4:10 a.m. Okay, so that's one interval. And then between these 2 points, so between 7:50 a.m. and 4:10 p.m., and then so between 7:50 p.m. and midnight, because it only asks for the first day. Okay, so it is past midnight as well, but it only said within the first day. So that's how we use our algebra here combined with our graph here to answer an inequality. All right, one more example, which introduces just one layer of difficulty here, where we are actually having to use our compound angle formulas and our double angle formulas. So we have sines and coses, not ideal. We can't really solve something with sines and coses. We need to express this as a single function. So it has to either have only sine, only cos, or only tan. So 2 sine x cos x, that is familiar to us. That is actually just the same as, here, I'll rewrite it. So 2 sine x cos x equals cos 2x. So I can't simplify this at all. I can't divide both sides by sine. That doesn't help me at all. If I just divide both sides by 2, that doesn't get rid of this 2, remember, because it's in the argument. So that doesn't help me. There's nothing to common factor out on either side, so that doesn't help me. So I'm going to go to my angle formulas. So 2 sine x cos x is actually just sine 2x. Oops. It's actually just sine 2x equals cos 2x. And you're like, okay, well, I still have a sine and a cos, so this doesn't help me. Okay, this is where the tricky part comes in, where might not be what you're able to come up with on your own. What happens if I divide both of these by cos 2x? Okay, I'm allowed to do it because I'm doing it to both sides, so they're both getting treated the same, so it's a legal move in math. I can do that. Why does that help me? I want you guys to think about that. Why does that help me? Well, what does sine 2x over cos 2x turn into? That reduces to tan 2x. And then this just reduces to 1. So now this is an equation that I can solve. All right, and I'm solving it between 0 and 2 pi, so I'm in radians again. All right, okay, so might not be as obvious to you that you're able to do that, but now that you've seen that trick, you have it in your arsenal for your homework, okay? So I can go ahead and solve this, and which is the same thing as solving this equation. So if I'm able to solve this equation, that's an equivalent equation to this one, so they will have the same set of solutions. So tan 2x is equal to 1. Well, tan is positive in 2 quadrants. It's positive in quadrant 1, and it's positive in quadrant 2. Okay, but I have tan 2x there, so I have to do this whole u equals 2x thing. So really, I just want to solve tan u equals 1. Okay, 1 comes from the special triangle here, where we have 1, 1, root 2, and this is pi over 4. So my beta is equal to pi over 4, okay? Because pi over 4 has a tan of 1. So then my u1 is actually just equal to pi over 4, since it's in quadrant 1. And my u2 is pi plus pi over 4, so it's equal to 5 pi over 4. Okay, so now I need to switch this back into x format. So 2x equals pi over 4. So therefore, x1 is equal to pi over 8 when I divide both sides by 2. And 2x is also equal to 5 pi over 4. So therefore, my second x value is equal to 5 pi over 8 as well. All right, now the trouble here is you have to remember that tan has a different period. So if you want to add 2 pi to this, that doesn't make sense, okay, because our period is just, it's been compressed. So we're just adding values of pi. So our x3 is going to be just pi over 8 plus pi. We're adding pi, and you get 9 pi over 8. And our x4 then is 5 pi over 8 plus pi, which gives us 13 pi over 8. Okay, so from here on, the process is the same as we've done in the rest of the note. It's this top part that it has some new strategies for you guys to learn. So make sure that in your note, you're highlighting that so that you know that's a part you need to study and pay close attention to. The rest is similar to the other examples. Here is where the difficulty lies, and you'll have to kind of study that and just practice a bunch of examples to make sure you're able to do that. All right, so here's some tips for you. And thanks for watching, guys. Hope you learned lots.